My name is Sanjana, and my project was the third eye for the visually impaired. My goal for the second milestone was to take the same circuit that I had constructed in the first milestone, but to make it wearable in order to build my base project. So what I did was I made a couple changes in order to incorporate that portable element. The first change I made was I changed from an Arduino to an ESP32 as my power source. So instead of having an Arduino as my microcontroller reading the code, I have an ESP32, which essentially has the same function but is more smaller and compact, making it easier to place on something like a glove. The next thing I had to do was I had to figure out how do I make it so I can fit all of these parts onto the glove. For that, I decided to use Velcro. This is because for someone who does want to change how it's structured, it would be an easy fix by just taking some Velcro and putting it elsewhere on the glove. The different parts I used were the ESP32, which is essentially my microcontroller, which is reading the code from the computer and outputting it to my different other output sources, like my ultrasonic sensor and my piezo buzzer for my base project. As I mentioned before, I've also used the same ultrasonic sensor, which is detecting the distance, and the piezo buzzer, which is helping someone to hear how far something is. Now, let's take a closer look at how I did it. As we can see here, this is just a model of my base project. I decided to use a gardening glove since it's a lot more durable and wouldn't exactly give way to the heavy parts that are being used in this prototype. Other than that, I have my ultrasonic sensor located at the fingers in order to detect the distance of an object from where the person is standing. I have my ESP32 over here and my piezo buzzer over here, which will then theoretically be attached to this palm portion of the glove. I have not yet done so in order for me to make it more accessible to add modifications if I would wish to do so. Now that we've discovered the main layout of the glove, let's take a closer look at the connections with the ESP32, the piezo buzzer, and the ultrasonic sensor. Although my connection to the ESP32 and the ultrasonic sensor are virtually the same as that of the Arduino, the main question is how did I connect my ESP32 electrically to the perf board? In order to do that, I utilize soldering. Soldering is a method where we use a hot iron that is heated to high temperatures in order to melt metal wires so it can conduct electricity. Let's take a closer look at the soldering aspect of this project. For this, I decided to use header pins in order to make the ESP32 removable. Therefore, I had to make two connections in order to connect the two header pins. Other than that, these longer connections are connected to my piezo buzzer, one connecting to the proper pin on the ESP32 and the other one connecting directly to ground, since my other ground pin was connecting to my ultrasonic sensor. The main thing with this project that I had difficulty with was indeed the soldering aspect of it. Now that we've gone in depth, let's have a demo of this project. For this demo, I'm going to be using a water bottle as my object just to show how the buzzer rapidly changes even while the project is wearable. As you can see, I've already connected my ESP32 to my computer, which is then running the code. In the future, I will be connecting this to a battery pack so that the ESP32 will store the code and the project will be made fully portable by having a power source strapped right onto the arm. Now that the glove is on, there are many ways I could test to show that it does indeed work. The first way is by putting my hand up here and closely bringing it at a slow pace. As you can see, the buzzer is rapidly beeping the closer I get. The next way is for me to use my hand as though I'm in a walking motion. As you can see, the buzzer is still moving at a rapid pace. Now finally, I'm going to move my water bottle closer to the ultrasonic sensor to show that the buzzer will still beep rapidly. Because this project is now almost fully portable, there are some goals I have for my final milestone. Of course, including a battery pack is a vital step in order to make this project fully portable. Other than that, another problem arises. This buzzer is so tiny and so soft that what happens if you're in a noisy setting? This is where my idea of including a vibrating motor comes in. There will be two buttons featured on this project. One, which is going to turn this project on and off completely, so that way it's not continuously buzzing or continuously vibrating. The second one is a button that switches between the vibrating motor and the buzzer, so that one may choose whether it's a small beeping sound or a vibrating feeling, so that one knows in a noisy setting if something is approaching or if it's not.